Hi friends, welcome to this presentation on exploratory data analysis with Python, also known as EDA. My name is Artemakis and today we'll explore how EDA can help you uncover valuable insights in your data using Python's powerful libraries. Exploratory data analysis, or EDA, is the process of analyzing datasets to summarize their main characteristics. This often involves visual methods, but quantitative techniques are also used. EDA is a critical first step in any data analysis project as it helps you understand the structure, patterns, and relationships in your data. The primary objectives of EDA include identifying patterns and trends within your data, detecting outliers or anomalies, checking for missing values, and understanding relationships between variables. Achieving these goals allows you to make informed decisions in the later stages of analysis. EDA typically follows a workflow that starts with data collection and loading, often using Pandas. Once the data is loaded, the next step is cleaning. This includes handling missing values and correcting any inconsistencies. After cleaning, data visualization comes into play using libraries like Matplotlib and Seaborn. Finally, you perform a statistical summary to gain a quick understanding of the data's distribution and central tendencies. So, let's discuss more about the EDA workflow by starting with data collection and loading. First, import essential libraries like Pandas, NumPy, Matplotlib, and Seaborn. Then, load your dataset using Pandas' read CSV function. It's always a good idea to preview your data with the pawn head function to ensure it has loaded correctly and to get an initial sense of what you are working with. Next is data cleaning. Begin by checking for missing values using isNullSum. Depending on the context, you can either impute missing values or drop them entirely. It's also important to ensure that each column has the correct data type, as this can affect your analysis later on. Finally, remove any duplicate entries in your data using drop duplicates. Data visualization is a key part of EDA. For univariate analysis, use histograms and box plots to understand the distribution of single variables. For bivariate analysis, scatter plots and heat maps are excellent for examining relationships between two variables. For multivariate analysis, pair plots and correlation matrices can help you understand how multiple variables interact with each other. The statistical summary phase involves generating descriptive statistics using Pandas' describe method. This gives you a quick overview of key metrics like the mean, median, and standard deviation for each numerical column. For categorical variables, value counts is useful for understanding distribution. Additionally, examining skewness and kurtosis helps you understand the shape of your data's distribution. To conclude, we've covered the essential steps in the exploratory data analysis process, from loading and cleaning data to visualization and statistical summaries. EDA is invaluable for understanding your data before diving into more complex analysis. I encourage you to explore these techniques further as they form the foundation of effective data science. Thank you for watching this lecture. For more insights on AI, databases, programming, and tech trends, subscribe to my channel on YouTube. Stay tuned for more knowledge-packed content.